Good morning, pre-algebra class. Today we are reviewing for a quiz on solving systems by graphing. And I have 3 different problems here that I'm going to do with you. So you kind of go over all of the different methods we used, all the different things that might come up. And the first one that we have at the top of the page here is just a simple system of equations that we're going to be finding the intersection point. So we have 2 equations for lines. They are both in slope-intercept form. And this is fairly simple. We're just going to graph them and see where they intersect. And that answer will then be given in an ordered pair. So this first one, if we start up at the 4, 1, 2, 3, 4, that's our y-intercept. The slope, remember, is 1 over 1. X plus 4, rise over run. So we're going to go up 4 over 1. Now, because I'm way up here at the top of the graph, it might be difficult for me to see where the intersection point might be. I'm going to change this and call it -1 over -1 x plus 4, which is the same as a +1. But I can take from this point and go down 1, back 1, and you see how it stays on the same line. And I'm going to keep putting points on here because I really want to be able to see where that intersection point is. Connect the dots and make my line. The second line, y equals 4x plus 1, starts at the +1 on the y-intercept. The slope is 4 over 1. Y equals 4 over 1, x plus 1. So I'm going to go up 4, 1, 2, 3, 4 over 1. And we can already see where they intersect. So I'm not going to bother putting any more points on there. They intersect at that point, which is, we have to name it, 1, 1, 2, 3, 4, 5. They intersect at 1, 5. Okay? So let's take a look then at the next one. This is the same kind of question, but it is in standard form. Both lines are in standard form. I want to change them and put them into slope-intercept form so that they look more like the one up above. So I'm going to start with the first one, x minus y equals -2. I'm going to solve for y. When I solve for y, I need to get rid of this x on this side. I end up with -y equals -x minus 2. I switched the order so it would be in slope-intercept form. And then I am going to divide out a -1 on both sides. This is really important and something I think that you guys miss sometimes. When I have a negative in front of that y, it comes along with it. And I then need to divide it out. So that's going to be a positive y now. -x divided by -1 is going to be a positive x. -2 divided by -1 is a positive 2. So now I can graph this. It's up 2 on the y-axis, and it's again up 1 over 1, up 1 over 1, or down 1, back 1. And this is my line. Let's tackle the second one, which is 2x plus y equals 2. 2x plus y equals 2. We're just going to subtract the 2x because remember we're trying to get y by itself on one side. When I do that, I get y equals, and I cannot combine those because this has an x and this one doesn't. So this is -2x plus 2. Okay? So if I graph this, it is up at the 2, and I can already see where it intersects. But you still need to graph the line correctly, so we go down 2, forward 1, because remember this is y equals -2 over +1 x plus 2. So down 2, forward 1. We can also call it +2, -1, which would give me a dot on the other side of my y-intercept. And again, you can see where it intersects. It intersects right here. Now this is kind of tricky sometimes for you guys. What is the ordered pair? When it crosses on the y-axis, the x value, it doesn't go in either direction anywhere. It stays right here. So it's 0 and then up 2. Okay. This last one is an inequality. So when we are graphing an inequality to find the solutions, we are not going to have one solution the way that we had one solution right here. We're going to have an infinite number of solutions. But what we're going to do here is graph them and shade them so that we can see where the region is where they overlap. So I'm going to start with this first one. These are both in y or slope-intercept form. So I'm going to graph them exactly the same way I graphed the lines of the other ones, but I have to pay attention to two special things. Whether or not my inequality has an equal sign under it, because that tells me whether or not I have a dashed line, and this one is going to be a dashed line because it does not have an equal sign. And the second one will also be a dashed line. Let's use yellow. If I had an equals, greater than or equal to, less than or equal to, that would be a solid line, and that is something that's very important. So I have this kind of tannish brown line on the top and the yellow that we're going to do two different colors here because we'll be doing some shading. And when you're shading, remember, this is a less than. We want to shade under the line. This is a greater than. We want to shade above the line. And something that I had mentioned to you before, you want to shade when you draw the line. Don't draw both lines and then try to figure out where to shade. You will confuse yourself. So let's start with this first one. We are down here at the -3 on the y. Okay. And we're going to go up 2 over 1 because that's the slope. And this question came up a good bit whenever you were doing your homework assignments. Do I have to give the intersection point? I have not been requiring you to give the intersection point of these two lines. And I'm going to show you why in just a second. Y is greater than 5. So this is, remember, if this were y equals 5, that would be a horizontal line at 5, which is right here. This one's going to be kind of tough to see. We're going to try to do the best we can. And I just did what I told you not to do, which is I drew both lines and didn't shade them. This first one is in brown, and it's a less than. And so we're going to shade under that line. Okay. I'm going to extend a little bit because I didn't have a graph large enough for this one. Extend a little bit further here. Okay. And then this one I am shading above. And I can't really see, I've kind of gone off the graph. But do you see where this intersects? It intersects and is double shaded right in this area right here. And I'm going to use a different color so that that's clear where that intersection is. And that is my answer. And the reason why the intersection point is not as important here as it might be in other questions is because this is the intersection point, which I didn't draw mine very carefully, but this would be the intersection point right here if I had drawn my line a bit more carefully. Make it more accurate. But because they are both dashed lines, that point is not part of our solution. The dashed lines means that the line itself is not part of the solution to the two inequalities, only the shaded region here. Okay? So if I chose the point maybe like, let's say 7, 7, that would probably be in my set of solutions up here. But if I chose the point -1, +1, that is not in any of the sets really, but it's not in my solution set here. So hopefully that helps while you're doing your review. If you have any questions, let me know, and as always, take care.